Now I'm going to discuss about the process of writing the transition probability matrix. Okay, so formation of transition probability matrix. TPM. So transition probability matrix. TPM means transition probability matrix. So how to form a matrix, transition probability matrix for a given problem. For a given problem. Now, here I would like to say one thing before going to construct the transition probability. And here, one thing you should remember the TPM of a Markov process. The TPM of a Markov process or Markov chain is a stochastic matrix. What is the meaning of stochastic matrix? That is each entry of the matrix are either 0 or greater than 0. There should not be any negative element in the matrix, in the transition probability matrix. So this is the first condition we have to see. And the second condition is summation over all j pij must be 1. That means over the row, whatever element will be there, the sum should be 1. So each of the element are either 0 or more than 0, but the sum of each element in a row must be 1, not more than 1. If these two conditions are there, then we can say the matrix is a stochastic matrix. So when we are constructing the transition probability matrix for a Markov chain, we should always see that the matrix is a stochastic matrix. That means each entry of the matrix should be non-negative and the sum of each entry in a row, not in column, in a row must be 1. It should not be more than 1. Then we can have the transition probability matrix. Okay. So now keeping this one in our mind, we can able to construct the transition probability matrix. Okay, let me take an example and we can construct the transition probability matrix for that. So how can we take, let me take an example here. Let me take one example here. Assume that a man is at an integral point. Man is at an integral point of the x-axis of the x-axis between the origin and the point between the origin and the point x equal to 3. X equal to 3. He takes a unit step. He takes a unit step either to the right, either to the right with probability with probability 0.7, or to the left, or to the left with probability with probability 0.3, with probability 0.3, unless he is at the origin, he is at the origin when he takes a step to the right, when he takes takes the step to the right. That means when he will be at the origin, he will not have the option of moving both left and right. He will have only one option, that he will move to the right. Similarly, when he will be at the point x equal to 3, he will be having only one option, that he can move to the left, not to the right, because x equal to 0 is the end point and x equal to 3 is also another end point. So unless he is at the origin, when he takes a step to the right to reach x equal to 1, to reach x equal to 1, or he is at the point, he is at the point x equal to 3, x equal to 3, when when he takes a step, he takes a step to the left, to the left to reach x equal to 2. Find the TPM. Find the TPM. Okay. So just I will simplify this one first, and then we will try to construct the TPM. So here what is I'm saying, a man is standing in an integral part of x-axis, which is starting at x equal to 0 and ending at x equal to 3. Okay, and at a time he can move unit distance. Unit distance means from x0 to x equal to 0 to x equal to 1. Okay, so I can say here x equal to 1. Then x equal, if he is there in at x equal to 1, then he can move to x equal to 2, not x equal to 3. From x equal to 0 to x equal to 2 he cannot move. From x equal to 0 to x equal to 3 he cannot move directly. He can move from x equal to 0 to x equal to 1, or he can move from x equal to 1 to x equal to 2, or x equal to 1 to x equal to 0. Whereas whenever he is starting from 0, he has no option to move left. Similarly, when he is at the point x equal to 3, he has no option to move right. The only one option is he has to move to x equal to 2 if he is at x equal to 3. Okay. So similarly, when he is at x equal to 0, he has only one option to move x equal to 1. Okay. So this is the simple explanation of this. Then how can we have the TPM for this? How can we have the TPM for this? So as I told you, in the TPM, the transition probability will be denoted by Pij, small pij. Small pij are the element of the matrix capital P. So what I will do here is I want to construct capital P. I want to construct this one. So here I will say that this is my present state xn minus 1. So this column I think I will say state x present state, and I will denote it as state xn future state. So depending upon xn minus 1 I will find xn. Now I have how many states? 0, 1, 2, and 3. So 4 states are there. So I will have here 0, I will have here 1, I will have here 2, and I will have here 3. Okay. And then what I will do here, similarly, here also xn minus 1 may be 0, maybe 1, maybe 2, maybe 3. Okay. So now see, the person is at x equal to 0. So present state is my x equal to 0. Now let me go to the future state. Future state is also 0. So present state is 0, future state is 0. So there is no probability of movement. So here the probability will be 0. Probability will be 0. Now suppose my present state is 0. My present state is 0. Now from present state is 0 means he has no option to move left, but he has only one option to go to x equal to 1. And so we will have the probability here 1, because he cannot move from x equal to 0 to x equal to 2. So only one option is there, x equal to 0 to x equal to 1. Hence the probability will be 1. Now my present state is x equal to 0 and future state is x equal to 2. So he cannot move directly from x equal to 0 to x equal to 2, and so there will be no probability, so probability will be 0. Okay. Now then present state is x equal to 0 and he cannot move to x equal to 3 directly, and so we will have here 0. Now you see that each element in this row are either 0 or 1. So sum of each element in this row should be 1. So 0 plus 1 plus 0 plus 0 is 1, and so it is fine. Similarly, I will go for my present. Suppose I will consider my present state 1. So if I am at the point 1, if the man is at the point 1 now, so he has two options. He can move to x equal to 2, or he can move to x equal to 0. But when he is moving to right, the probability is 0.7. But when he is moving to left, the probability is 0.3. So when he is at presently he is at the point x equal to 1, then if future state is 0, so 1 to 0, that means he will move with the probability 3. And from x equal to 1 to when he will move to x equal to 2, he will move with, so again present state is 1, future state is 1, so there is no movement, so I will have the probability 0. Now if he is at the point x equal to 1, he can move to x equal to 2. So since he is moving forward or to the right, so it will be probability 0.7. Now you see that moving to 0 is 0.3, moving to 2 is 0.7. If I take the sum of this, and so I will get 1, and the other thing definitely it will be 0. Definitely it will be 0. Now let us consider our present state is 2. That means now the man is at the position x equal to 2. So if he is at x equal to 2 means he can move right to reach x equal to 3, or he can move left to reach x equal to 1. But when he is moving to the right to reach 3, he will move with the probability 0.7, and he is moving to left to reach x equal to 1, he will move with probability 0.3. So now present state is 2 and future state is 0. He cannot move from 2 to 0 directly, so the probability in that position will be 0. Now x equal to x equal to 1 he can move, and he can move to the left, and so the probability is 0.3. Similarly, x present state is 2 and future state is 2, so there is no movement, and so I will have a probability here 0. Now present state is 2, future state is 3. That means he has to move to right, and the probability will be 0.7. Now you see sum of each element in this row will be nothing but 1. Now let me take x equal to 3 is my present state. Now the man is at x equal to 3. So x equal to 3 means there is no option to move to right because it is the end point. But there is one option, only one option to move to left. Okay, so if he is moving to left, that doesn't mean that here probability will be 3, because if he is at 3, he cannot go again to 1, he cannot go again to 0. So those two probability will be 0. So only one option will be there when he is moving from x equal to 3 to x equal to 2, the probability will be 1. So if my present state is 3, future state is 0, there is no movement, direct movement, and if a present state is 3 and future state is 1, so there is also no direct movement. But when he will have when he is having at x equal to 3, he can move to x equal to 2 with a certain probability, that is 1, and present state is 3, future state is 3 means it will be 0. So this is the TPM corresponding to the problem. So like this we can able to construct the TPM for a Markov chain. Okay. So here only one thing we have to remember: when we are constructing the TPM, we should remember that it should be a stochastic matrix. Okay, stochastic matrix means each element is either 0 or more than 0, and sum of each element in a row. So this first row, in the first row you see my sum is 0 plus 1 plus 0 plus 0. So sum is 1. In the second row you see 0.3 plus 0 plus 0.7 plus 0. Again 1. In the third row you can see that 0 plus 0.3 plus 0 plus 0.7 plus 0 is equal to 1. And here I am having 0 plus 0 plus 1 plus 0. So each row, the sum of the element must be 1, not more than 1. Okay. So this is the thing we should remember while constructing the TPM for a Markov chain.